Hello everyone. In today's video, I want to look at introduction to integration and having a look on the basic formulas for integration. Now, let us start with this. Let y then add the integral sign with respect to x. We write the x is equal to, we raise the power of x by 1, then we divide by the new power, which is n plus 1, then we add the constant c. At that point we see that the integral sign is that one and y. Then when we say with respect to x, we mean dx, and then the power raised has become n plus 1, and then divided by n plus 1, n plus constant c. Now in the next step, let us see how we can get this formula, or where did it come from. Just so you need to know that integration is just the opposite of differentiation. Let us prove the formula. So let's consider dy dx equal to x raised to some n. Of course, dy dx, we looked at it in the previous videos under differentiation. So from here we shall use method of separation, though we haven't studied it, but we shall look at it. And then from here we shall have that our dy will be the same as, if you do cross multiplication, x power n, then dx. Then applying the integral sign, apply integrals, we get then the y is equal to integral x power n, then dx. Now at this moment we see that we have integral of dy. This one is still the same as 1 then dy. But from indices we know that 1 can be written as y power 0, and then the dy will be equal to integral of x power n dx. Then from this point we shall get, if we integrate these two, it means that using the previous formula we can have that we know it will be y power 0 plus 1 divided by 0 plus 1, then is equal to the right hand side, it will be x power n plus 1 divided by n plus 1. Then we have seen that if you integrate, we just add a constant, then we shall have plus c. Now from this point we shall get what? We shall have y is equal to x power n plus 1 divided by n plus 1, n plus constant. So meaning that also this formula can be used under differential equations. Okay, so with that side we shall be able to do some derivations more than this. So in the next step, let us have, so the first one is indefinite integrals. Here we deal with integrals without limits. What do we mean by limits? In the next question, this thing like integral from maybe a to b, those are what we call limits. But for indefinite integrals, we don't have their limits. Then we shall also have a look at what we call definite integrals. Let us also have its definition. Now, under definite integrals, where we shall look at integrals with limits, that is from a to b with respect to x. That is integral of a to b y and dx. Let us go directly to the examples. So in this video we have already looked at the formula for integration, the previous one. So here we just need to apply it. Let us just apply the formulas we have already finished, so that if y is equal to x power n, we just need to raise the power by 1. Now for instance, for a, shall say that y is equal to x power 4. We looked at if we want the integral, we shall have the integral of y with respect to what? To x is equal to x power 4. Let us also put there dx, and then we do like that. So these are what we call the indefinite integrals. There are no limits. Now y we know it is equal to x power 4, so we shall say integral x power 4, x will be equal into, we shall have x power 4, then we raise the power to, say plus 1 divided by 4 plus 1 and this plus 1, then plus constant c, and so the final answer will be, this is 4, x power 4 plus 1, it will be x power 5 divided by 5 then plus c. And now this is what we have as the solution of the integral of x power 4 dx. What did we do? We just raised the power of x, which was 4, we just took it to 4 plus 1, and now also we divided by 4 plus 1, and now the final answer has become the integral of x power 4 is equal to x power 5 then plus c. Let us go to the next example. Yes, now we have b, which is x power 5 minus x squared plus 1 divided by x squared. So for this start, just say let y is equal to x power 5 then minus x squared then plus 1 divided by x squared. We shall just use indices and we divide since it is possible. So we shall have the integral of y with respect to x will be equal to x power 5 divided by x squared integral, then minus x squared divided by x squared, then plus 1 divided by x squared. Then we need to put this integral outside. Yes. Now, what do we do here? It's better you first simplify it. Here, due to indices or using the index formula, we shall have to be the integral of x power 5. This one will become x power 3 minus x squared over x squared. So you reduce and then you get minus 1. And then this one, if you do it and simplify, it will be minus, it will be plus x2 minus 2, then c. So since we are the start, it's better you do them one by one. How? We shall have integral x cubed dx, then minus integral of 1 dx, then plus integral of x power minus 2 dx. Then what shall we get here? We shall see that it's a matter of raising the power of 3, it will go to 4, meaning that here we shall have x power 4 divided by 4. And also, if we go to 1, this one the same as we have there x power 0. This one the same as x power 0. Yes, so meaning that shall raise the power of x power 0, so the thing will go to minus x power 0 plus 1 divided by 0 plus 1. Then plus, when you go on this one, it will be x power minus 2 plus 1 divided by minus 2 plus 1. The moment you finish integrating, maybe on the right hand side, all of the independent variable which is x, you have there a constant c. And now what shall we get as the final answer? To be 1 out of 4 x power 4, and then this one resolved into minus x power 1, and then this one will be minus, it will just come up, so this one will give us a minus, so we shall have minus x power negative 1. And then of course this formula we can still reduce it to 1 over 4 x power 4, then minus x, then minus 1 out of x. So this is the formula of integral of y then dx. So this is the solution for that part. Let us go to part C. Yes, we'll go to C plus C, so that is the solution. For part C, it is a function of t. So meaning that at this point you are going to be having the integral of y with respect to t is equal to, if you integrate the right hand side, 5t power 3 minus 10t power minus 6, then plus 4, then there we shall put what we call dt. Then since we already use it, meaning that at this point I don't need to do one by one, so let me just do it once. So we are going to be having 5, and then our t, we just deal with the variable which is t. 3 plus 1 divided by 3 plus 1 minus 10, then here it will be t power minus 6 plus 1 divided by minus 6 plus 1, then plus, we saw that when you integrate 4 it is the same as 4, then t power 0, so we shall add there 1, then divided by 0 plus 1. After integrating, we add what we call a constant c, and then if we simplify this, it will go to 5, then t power what? Power 4 divided by 4 minus 10, then t power minus 6 plus 1 to be minus 5, then the whole of this divided by minus 5, then plus 4, then t to power 1 divided by 1. The whole thing is equal to, okay, plus c. And then we can just simplify the end, and we say the integral of y with respect to t is given by 5 out of 4, then t power 4 minus 10 divided by minus 5, it will give us a positive, so we shall have 2 t power minus 5, then plus 4 t, then plus c. That is the solution of part C. So let us also go directly to the indefinite. No, we have finished indefinite. Let us go directly to definite integrals, or the one with limits. So now let us look at the definite integrals. So we see that if f equaling to the integral of f a small function, can have it like that, maybe you have seen it. Also, maybe if you had a function of y and then we decide to integrate it, and then we get f, meaning that capital F is the integral or the general integral of the whole function, then we can get the solution if given integral limits, like from a to b. It can be got from the integral of f from a to b is equal to capital F as a function of b, then minus capital F if we substitute a. So let us look at examples. So let us look at these examples. For part A, we have integral of x squared plus 1 dx. We are doing about this from the previous formulas. This one will be x we raise the power by 1, which will be power 3 divided by 3, then plus, if we integrate 1, we shall get x. But of course, we saw if there are no integral limits, we just say plus c. Now, what about when there are limits? If there are limits, which is from 0 to 2, x squared plus 1 dx is equal to the constant. There is no need to put it there, but Even if you put it there, it will cancel. So we always just have use square brackets or vertical line on both sides. It will be x cubed over 3 then plus x, then you can do like this, and then you write 0 here, then we write 2 here. But from the formula you are seeing up, we have that if the integral of f is equal to capital F, it's a matter of substituting b first, then you subtract it if you substitute a. So from this one we shall have 2 cubed divided by 3 plus 2. First compare this, then minus, if we substitute the, so it will be 0 cubed divided by 3, then plus 0. What will be the answer here? It will be resulting into 8 over 3, then plus 4, plus 2, very sorry, plus 2, and then minus, if you substitute those, it will be 0. And so the answer will be, if you put this on the calculator, we are going to get 8 plus 6 over 3, and the whole thing will be 14 out of 3. And therefore the integral of x squared plus 1 with respect to x, if you put this from 0 to 2, the answer is equal to 14 divided by 3. So that's how we apply the limits. Okay, maybe we can also check on part B and we see. On part B we have integral of 4y squared plus 2y then dy. So according to what we have already seen, just say 4, then we raise the power. It will be y power 3 divided by 3, and then plus 2, and then y raised to power 2 plus power 1. Yes, so we say divided by 2, then plus the constant. You can just do it at once. You put the limits, which is complete. So then if we put the limits from 1 to 2 of 4y squared then plus 2y dy, the whole thing will be going 4 out of 3 y cubed plus y squared, then use the square bracket from 1 to 2. Then we again put the formula up. We shall do a function of b minus a function of our b is 2. So we shall have 4 out of 3 times 2 power 3 is 8. Then plus 2 power 2 is 4. Then minus, if you substitute 1, 4 out of 3 times 1 cubed, which will remain 1, then plus 1 squared, like this. And then what shall we get to be going to be 4 times 8, that one will be 32 divided by 3, then plus 4, then minus 4 over 3, then plus 1. Because if you solve this one, we can be able to get the answer. So if we adjoin, it will be 32 out of 3, it will be 44 out of 3 minus 7 out of 3. And so the final answer is expected to be around 37 out of 3. So that is the solution. Maybe you can take time and solve some numbers, then just give you. So you can try these numbers in your free time. First one, x squared, and this plus 6 with respect to x. Then for b, you try x power 6 plus 8x squared divided by x power 5. Then x. I think this one is enough. Very thank you for watching. Take time to share to your friends that you can learn this. Alright. Thank you.